Hi guys, welcome to at-home video here. I'm going to be making these videos hopefully a couple times a week for most of the lessons we're going to learn because they're a little bit tricky and I'm afraid you'd have some difficulty if I had to have you learn this on your own. When I do these, I'm always going to try to reference what section in the book we're doing. We're in chapter 8, if you remember, on rational functions. This can be found in section 8.4. So if you want to get your online book or your book, look at things and read some more about it, you're going to be able to do that. All right, now if you remember, we're working on rational functions. A rational number is a number that can be written as a fraction. So if you remember, a rational function is a function that looks like a fraction where the numerator and denominators are polynomials. We've graphed them already. We looked at where the asymptotes, remember they were hyperbola, they had two branches, they had two asymptotes. We learned how to find where the asymptotes were at. Now we're going to start working with rational functions, and today we want to look at how we simplify them. So here's the very simplest kind of rational function we can have, where the numerator and denominator are constants. And I know that if I told you to simplify this, you would tell me the answer is 4/5. Now, let's not think grade school where you say, all right, yeah, I pull this magic 3 out of the air because it's a common factor and I divide both and I don't know where the 3's go, but I get 4/5. No. What we're really doing is writing that as 3 times 4. This is 3 times 5. The 3's don't disappear. I don't like the word cancel. They become 1, and 1 times 4/5 is 4/5. All right, if we look at the next one, we can use the same strategy. We're looking for common factors in the numerator and denominator that can actually pair to form 1, to become 1. So I'm going to write the 9 as 3 times 3. This 3 and that 3 become 1. This x and one of these x's becomes 1, leaving an x to the third, and the y's become a 1. So what I am left with here is an x to the third over 3. Now, that's baby food. That's all Algebra 1 stuff, okay? Let's move on to our middle school years here a little bit. All right, now we said the key was that you had to find a like pair of factors in the numerator and denominator that could become 1. Now here's the key. Factors are separated by multiplication. So in the denominator, this is a factor, this whole quantity. This is a factor. X is not a factor, 3 is not a factor. Those are separated from each other by addition. Those are not individual factors. In the numerator, 2 is a factor, and x plus 1 is a factor. So yes, I can take this entire quantity, and those can pair up to be 1, and my final answer is 2 over x plus 3. We don't need those parentheses around the x plus 3 in the denominator because the fraction bar puts understood parentheses around the numerator and denominator. All right, now let's look at the next one. It's a little more challenging. I know you're going to be wanting to just start saying 10 goes in there 4 or whatever, and 10 goes in there, that's 2 over 3. We can't do that. 30 is not a factor, 20 is not a factor, 10 is not a factor, 10x is not a factor, okay? These addition signs are messing us up. So what we have to do is factor first. Those are not in factored form. So I'm going to factor first. And how are we going to factor that? We have 3 basic ways to factor. Trinomial reverse FOIL, but those are not trinomials. Difference of 2 squares, but I don't see squares and I don't see subtraction signs for differences. So my only other method is the one we usually forget about, GCF. So I am going to take a GCF of 20 out of the numerator, and that is going to leave me with 2x plus 1. I'm going to take a 10, that's the greatest common factor, out of the denominator, and that's going to leave me x plus 3. All right, now 20 becomes a factor. This whole quantity is a factor. 10 is a factor. This whole quantity is a factor. So I can't do anything with those. The whole quantity has to be the same, or I can't do anything with it. What I can do is write 20 is 10 times 2 and pair that 10 and that 10 up. So unfortunately, this is one that's not going to simplify too much, and this one is just going to be 2 times 2x plus 1 all over x plus 3. Now, you don't need to multiply that out in your final answer. I don't want you to waste time having to do that. You can leave it in factored form like that. If you check answers in the book, they'll probably multiply it out, but I'm not going to require you to do it. Okay, next one. Here we go. 4x over x plus 2. Now this is an interesting one. In the numerator, that's already multiplication. So 4 is a factor and x is a factor. And I know you're going to want to really badly pair those x's up. But you cannot, because x is not a factor of the denominator. This is prime, it cannot be factored. This whole thing is the factor. It's like x plus 2 times 1. So there actually is nothing I can do, so this cannot be simplified. Boom. Okay, nothing I can do. Don't you be tempted to slash away at those x's, okay? That's man-slashing, and man-slashers go to jail. All right, 3 more, and then we'll be done. So the top one, I have to factor first. So if you I can't do anything with the numerator. That's prime. The denominator, I hope you recognize as the difference of 2 squares. X plus 4, x minus 4. This and this become a 1. My answer is not x minus 4. It's 1 over x minus 4, because the x minus 4 is left in the denominator. Okay, next one. Now I got some trinomials. So trinomials, we reverse FOIL. First term is x squared, so I need an x and an x. Only factors of 3 are 3 and 1. That makes that pretty easy. I want to get a -2 from my inners and outers, so the 3 is going to have to be negative and the 1 is going to have to be positive. All right, the denominator, x and x. Now I could use 6 and 1 as my factors, or 3 and 2, but since the middle term is a 1, I think you know we want to use 3 and 2. And since I want a -1, the 3 will have to be negative and the 2 will be positive. Remember, firsts are going to give me my x squared, the lasts are going to give me this, the inners are going to give me -3x, the outers will give me +2x, those will combine for my -1x. All right, last one. All right, got to do some factoring here. Top is not a trinomial. It's not difference of 2 squares. This is my old GCF. I'm going to take out a GCF of 2x. It's going to leave x plus 5. Denominator is a trinomial. This one's a little tougher because I got that 3 there, but not too tough because the only way I can split it up is 3x and x. Now this one's not too difficult because 5 only has 1 pair of factors, 5 and 1. The question is, do I put the 5 here and the 1 there, or the 1 and the 5? And hopefully you can figure that out. But my instinct's going to tell me I want the 5 here so that I'll be able to do some simplifying, and the 1 here, so I better check this out. The inners would give me 1x this way, the outers would give me 15x, and that's going to add up to give me my 16x. Voila, okay. So then this factor and this factor become 1, and my answer is 2 over 3x for this one. Okay, so that's that lesson. Check Power School calendar on the dashboard. See what the assignment is that goes along with this. I don't know that I've decided yet if it's going to be a Delta Math, a book assignment, or a worksheet. If it's a worksheet, it's going to be attached on the PowerSchool page for this week. If it's a Delta Math, you'll just see the Delta Math. Well, maybe I'll put it both places, but I'll put it on the dashboard. And if it's a book assignment, it'll be on the dashboard and on the PowerSchool page. All right, guys, thanks a lot. See you next time.